Hello everyone. Let us start with convolution operation. In the convolution, we come across two types of operation, that is convolution sum and convolution integral. Convolution sum is associated with the discrete time system, whereas convolution integral is associated with continuous time system. Okay. Now let us start with convolution sum here. The first problem is like this: evaluate the discrete time convolution sum given below, that is y of n equal to u of n convolution of u of n minus 3. We have to perform the convolution sum operation now. Before starting, we will consider from the given question, we will assume or we will consider x1 of n as u of n, x1 of n as u of n, and x2 of n as u of n minus 3. Okay. From the given question, we will consider this as x1 of n and this as x2 of n. Okay. Now we will draw the first two signals, that is x1 of n and x2 of n. As you all know, x1 of n is u of n, that is much step signal it is. It is a step function. Okay. So the step function is from 0 to infinity. The standard signal step function is lies from 0 to infinity with the amplitude 1. This is your x1 of n. 0 to infinity with the amplitude 1. This is x1 of n. Whereas x2 of n is u of n minus 3. There is a right shifted signal. There is a right shifted signal. So the signal is shifted to the right side by 3 intervals. So signal will start from 3 to infinity. It is also step signal. It is also step signal, but it is a right shifted signal. So signal will start from 3 to infinity with the amplitude 1. This is your x2 of n. Okay. Now we have obtained x1 of n as well as x2 of n. Now we'll start with solving with the formula here. Now as we proceed with the formula, we have the formula y of n equal to x1 of n convolution of x2 of n. Okay. And the standard convolution sum formula is given by y of n equal to summation k equal to minus infinity to plus infinity x1 of k into x2 of n minus k. This is the main formula for convolution sum. Okay. So in order to obtain y of n, in order to solve this convolution summation, we need to obtain x1 of k and x2 of n minus k. Fine. This x1 of k and x2 of n minus k are obtained from these two signals, that is x1 of n and x2 of n only. Okay. Now the first term x1 of k. x1 of k is obtained by replacing n by k. By replacing n by k. Okay. In the first signal, whatever first signal we have, this is x1 of n. Okay. In the first signal, we will replace the variable n by k. So we will obtain x1 of k. So we will obtain x1 of k just by replacing n by k from the first signal. That is, we will obtain the same signal, that is step signal from 0 to infinity with the amplitude 1 and with the parameter with the interval k here, with the time interval k. This is your x1 of k, same as that of your first signal. Fine. Now this x2 of n minus k, this x2 of n minus k is obtained by considering n equal to 0, if consider n equal to 0, and by taking the mirror image of the second signal. Okay. If you make n equal to 0, will remain with x2 of minus k. Again same, just replace n by k, will get x2 of minus k. Since we have minus, we have to take the mirror image. Fine. x2 of n minus k we have, will consider n equal to 0. Okay. We have x2 of n minus k. If you make n equal to 0, it will get x2 of minus k. Okay. Same here, as we done here, we replaced n by k, so we get this one x1 of k. Here also we will replace x2 of n by x2 of n by k, will get x2 of k, and we will take the mirror image. And we will take the mirror image. If you take the mirror image, initially the signal is from 3 to infinity. If I take the mirror image, now it will become minus 3 to minus infinity. Now we will obtain from minus 3 to minus infinity. Okay. This is your x2 of n minus k. This is your x2 of n minus k. Now we obtain the final signals, that is x1 of k and x2 of n minus k. Okay. Now we will perform the convolution operation. Okay. How means the signal, this term, the origin is considered as k equal to n, because we have considered this as interval k here. So let us consider this point as k equal to n, this as k equal to n minus 3. Okay, this is the origin. This is the starting of the signal here. This is starting of the second signal. So this point is considered as k equal to n minus 3. Suppose signal starts from here means it will be k equal to n minus 1. If the signal starts from here means k equal to n plus 1. Whereas now the signal is starting from minus 3 interval. So we'll consider this point as n minus 3. Now we'll consider two cases. Okay, whenever this n minus 3 point is less than 0, and whenever that n minus 3 point is greater than 0. Okay, so we'll consider the second signal, we'll go for comparison of second signal with respect to first signal. Okay, the second signal point is n minus 3. Whenever this n minus 3, the whole signal n minus 3 signal is less than 0 and greater than 0. Okay, once we make less than first signal, once we make greater than first signal, we'll consider the cases now. Okay, if I make n minus 3 less than 0, okay, n minus 3 less than 0 means there we cannot perform any multiplication. There is no any multiplication operation. Okay, because the signal will not overlap. One signal will be here and one signal will be here. There is no any overlap. So the convolution operation will yield 0, will result in 0. Okay, will result 0. And the second case, when we make that n minus 3 is greater than 0, there will be overlap, because here we have the signal. If we make this greater than 0, there will be overlap of the two signals. So we can go for convolution operation. Okay. Now summation, we have k equal to minus infinity to infinity, that is replaced by 0 to n minus 3. Why? Because this is the first case. Okay, there's 0. Okay, one more is n minus 3. Okay, one point is 0 and one point is n minus 3. Okay, x1 of k, x2 of n minus k. x1 of k and x2 of n minus k are nothing but the step signals. Both are step signals and the values are 1. Okay, and the values are 1. If you substitute with 1 with the help of the standard function, okay, we have the standard function, that is k equal to 0 to n minus 2. With 1 we have means we'll write it as n minus 1. Okay, so we have 0 to n minus 3, we have 1, so we consider as n minus 2. Because this is a standard formula we have, so we'll consider as n minus 2. Okay, so y of n is 0 for n minus 3 less than 0, and it is n minus 2 for n minus